A handful of questions on the reading and writing section of the digital SAT will be accompanied by an infographic. If the released practice tests are any indication, that infographic is most likely going to be a graph or a table, but it could be some other kind of visual representation of information. Mr. Greenberg, those questions are a piece of cake. I mean, how hard can it be to read a graph? Hold up, student me. While it is true that you will often need to be able to read and interpret an infographic in order to answer these questions correctly, the ability to read and interpret an infographic is just a small part of the process. And in fact, in many cases, you won't need to look at the infographic at all. So when you see one of these questions, if your instinct is to jump straight to the graph, stop, because you're probably wasting your time.
So then what should I do?
Well, student me, stay tuned, because in this video, I'm going to give you 4.5 steps that you can use to answer infographic questions quickly, confidently, and above all, correctly.
4.5 steps?
We'll get to that. So the first step is to read the question and determine what you'll need to know in order to answer it. Let's try that with a simple example. Now again, we're just going to pretend that the infographic doesn't exist and we're going to jump straight to the question. Let's try reading it together. Which choice best describes data from the graph that support the researcher's conclusion? So what we need to know is the researcher's conclusion, because we can't support the researcher's conclusion if we don't know what that conclusion is. Now that we've determined what we need to know, we're ready to move on to step number 2. Read the text, looking for the information you'll need to answer the question. Let's return to our example question and try that out. So just glancing at the text, I can tell you that the researcher's conclusion is probably going to be in the last sentence, the one that begins according to the researchers. So let's read that one together. According to the researchers, the findings suggest that across the years analyzed, there was a growing interest among CEOs in connecting with more departments in their companies. So now that we've found the relevant information, we're ready for step 3. Predict an answer to the question. So this step is the simplest one in some ways because it's a logical extension of steps 1 and 2, but it's also an extremely important step. Because how are you going to be able to recognize the correct answer if you don't know what the correct answer is going to look like? Now, returning to our example, we know that we need to support the researcher's conclusion, which is that there's a growing interest among CEOs in connecting with more departments. Now, the word growing is a key one because it implies change over time. So the correct answer must show that, with time, there has been an increase in CEOs' interest in connecting with more departments. Now that we know what to look for, we're ready to move on to step 4. Read the answer choices and reject anything that doesn't match your prediction. Let's try that together with our example, starting with choice A. The average number of managers and department leaders reporting directly to their CEO didn't fluctuate from the 1991 to 1995 period to the 2001 to 2008 period. Now, answer A does relate to CEOs connecting with departments, but it doesn't show an increase in interest over time because it says the number of department leaders reporting directly to their CEOs didn't fluctuate, which means we eliminate it and move on to B. The average number of managers reporting directly to their CEO was highest in the 1996 to 2001 period. Now this one is even easier to eliminate because it doesn't relate to departments at all, so we can cross it off and move on to answer C. The average number of department leaders reporting directly to their CEO was greater than the average number of managers reporting directly to their CEO in each of the 3 periods studied. Now this one is a little bit trickier to rule out, but if we look closely, we'll notice that it's simply comparing the number of department leaders reporting to their CEO to the number of managers reporting to their CEO. It doesn't tell us anything about more department leaders reporting to their CEOs over time, which is what we need to satisfy our prediction. Therefore, we can cross it off and move on to answer D. By now, it's the only answer we've got left, so it better be correct, but let's read it together just to confirm. The average number of department leaders reporting directly to their CEO rose over the 3 periods studied. Now, as you can see, this does indicate an increase in connections between CEOs and department leaders, which means it matches our prediction. Therefore, it must be the correct answer. We can pick it confidently and move on to the next question. Notice how we didn't even need to look at the graph? Pretty cool, huh? In fact, if we had looked at the graph, it probably would have just confused us because answers C and D are both factually correct according to the information in the graph. It's just that only D satisfies the goal.
Mr. Greenberg,
What is it, student me?
Didn't you say there were 4.5 steps?
Good memory, student me. The last step, the half step, is to look at the graph. And the reason I'm calling it a half step is because, as we've just seen, sometimes you won't need to do it. But sometimes you will, either because you'll see multiple answers that satisfy the goal, or because you'll need to reference the graph in order to determine whether a particular answer satisfies the goal. Let's take a look at another example, one in which you will need to take that extra step. So again, we start by ignoring the infographic and jump straight to the question itself. Which choice most effectively uses data from the table to complete the statement? Now the question is asking for information from the table to complete the statement, which means that we'll need to focus on the statement, the one with the blank in it. So let's read that together. This can be seen most clearly by comparing the employment by sector in both countries in blank. Now the phrase "this can be seen" tells us that we're going to get an example. But an example of what? To find out, we need to know what "this" refers to, which means we'll need to read the previous sentence. This transition happened at very different rates in the 2 countries. So it seems that this is the fact that this transition happened at very different rates.
Mr. Greenberg.
Yes, student me?
But what's this transition?
Great question, and unfortunately to answer it, we're going to have to backtrack one sentence further. Over the past 200 years, the percentage of population employed in the agricultural sector has declined in both France and the United States, while employment in the service sector has risen. So to put it all together, in both France and the United States, employment in the agricultural sector has fallen, but in the service sector, it's risen. But this transition has occurred at different rates in the 2 countries. So moving on to step number 3, we know that the correct answer will show us a rapid or significant change in one of the countries and a relatively slow or insignificant change in the other. Now we're ready for step 4. But this is where things get a bit more complicated. Because to understand the answers and determine whether or not they match our prediction, we're going to need to reference the table. Let's try that together. Now, A is asking us to compare employment by sector in both countries between 1900 and 1950. Looking at the table, we can see that between 1900 and 1950, agriculture in France fell from 43 to 32%, while services rose from 28 to 35%. That seems like a fairly moderate change. Now looking at the US, between those same years, agriculture fell from 41 to 14%, while services rose from 31 to 53%. That's a much bigger change, which means that answer A appears to match our prediction, so it's probably correct. And if you're short on time, you may decide to pick it and move on to the next question. But for the sake of practice, let's examine the other answer choices together. Answer B is asking us to compare employment by sector in both countries between 1800 and 2012. And looking at the table, we can see that between those dates, agriculture in France fell from 64 to 3%, while services rose from 14 to 76%. That's a fairly significant change. Meanwhile, in the United States, agriculture fell from 68 to 2%, while services rose from 13 to 80%. Those numbers are also significant and correspond fairly closely to the numbers we saw for France. Therefore, B does not show that the transition happened at very different rates. In fact, it shows that it happened at similar rates, which means we can eliminate it and move on to answer C. Answer C is asking us to compare employment by sector in both countries between 1900 and 2012. And looking at the table, we see that between those dates, agriculture in France fell from 43 to 3%, while services rose from 28 to 76%. Meanwhile, in the United States, between those same years, agriculture fell from 41 to 2%, while services rose from 31 to 80%. Again, those changes are fairly comparable, which means we can safely eliminate C and move on to D. Answer D is asking us to compare employment by sector in both countries between 1800 and 1900. And looking at the table, we can see that between those dates, agriculture in France fell from 64 to 43%, while services rose from 14 to 28%. And in the United States, agriculture fell from 68 to 41%, while services rose from 13 to 31%. Again, those numbers are fairly similar, which means we can safely eliminate answer D, confirming that answer A was, in fact, the correct answer choice. Now let's look at one final example, one that's just a little bit harder to reinforce what we've learned. But before we do that, a quick public service announcement. I've recently started an Instagram account where every week I'm going to be posting one new practice question. I also have a ton of resources available for free on my website, Ivy League Mentors Prep. So if you're looking for additional practice resources, I suggest you check them out. I'll leave the links in the description. Now let's get back to the question. As usual, we'll begin by ignoring the infographic and focusing our attention on the question itself. Which choice best describes data from the table that support the researcher's claim? Now, to answer this question, the first thing we're going to need to know is the researcher's claim. So when we read the passage, we're going to focus primarily on finding that information. Now, just glancing at the text, I can guess that the claim is probably going to be in the final sentence, the one that says, "they claim." So let's read that one together. Based on these results, they claim that plants of these species that grow in close proximity to other plants gain an advantage at an early developmental stage. Again, we'll have to backtrack a little to make sense of this sentence, but if we do, we'll see that they is the researchers and that these species are the 5 species in the experiment. So here's where we have to stop for a moment and think. What kind of information would be needed to support this claim? It may be impossible to make a precise prediction, but if plants that grow close to other plants gain an advantage, we might expect that they grow larger or more quickly or that more of them survive. There's also an implied comparison. Gain an advantage over what? So the correct answer will probably show that plants that grow near other plants are somehow more successful than typical plants, or something like that. Now that we've made a prediction, we can move on to the answer choices, examining them one by one and rejecting anything that doesn't match our prediction. Let's start with answer A. For all 5 species, less than 75% of juvenile plants were growing in patches of vegetation. Now let's break this down. Plants growing in patches of vegetation do seem to be growing in close proximity to other plants, so that part seems to match. But what about this 75%? On one hand, it sounds like a high number, but the fact that the answer says less than means that the actual figure could be much lower than that. It's difficult to interpret. We have a much bigger issue on our hands, though, because the real problem is that there's no comparison being made. So even if plants growing near other plants appear to be successful, we can't say that they have an advantage over typical plants, or any other kind of plants for that matter. That means we can cross off answer A and move on to B. The species with the greatest number of juvenile plants growing in patches of vegetation was H. stoechus. Stoechus? Who cares? We'll just call it HS. Now this one does have a comparison. It's comparing HS to other species in the experiment. But is that the comparison that we wanted to make? We predicted that for all species, plants growing near other plants would have an advantage over plants that don't. And that's not what we're getting here, which means we can safely eliminate it and move on to answer C. For TL and TM, the percentage of juvenile plants growing in patches of vegetation was less than what would be expected if the plants were randomly distributed. Now this answer is also making a comparison, and this time it's the right comparison. It's comparing plants that grow near other plants to typical plants, those that are randomly distributed. But does it suggest that the plants growing near other plants have an advantage? The idea that there are a lower percentage of them growing appears to suggest the opposite. And the fact that this answer only mentions 2 specific species is also problematic, because the claim was about all 5 species. Therefore, we can cross off answer C and move on to answer D. Again, we've already crossed off everything else, so D should be the right answer. But let's read it and confirm that suspicion. For each species, the percentage of juvenile plants growing in patches of vegetation was substantially higher than what would be expected if the plants were randomly distributed. So this answer is also making a comparison between the plants that grow near other plants and typical plants, the ones that are randomly distributed. And the fact that a higher percentage of them are growing near other plants than would be expected suggests that they may gain some sort of advantage from doing so. Moreover, it says that this is true for each species, which was an important part of our prediction. Therefore, we can be confident that D is the correct answer.
But Mr. Greenberg, answer D isn't supported by the table.
Are you sure about that?
Sure, because the table just has 2 categories, bare ground and patches of vegetation. It doesn't say anything about the plants that were distributed randomly.
You're right, student me. It doesn't, and I suspect that's why many students get this question wrong. However, if you look back at the text, it tells us that if the plants were randomly distributed, only about 15% would be in patches of vegetation. And the table tells us that for all 5 species, the percentage of plants growing in patches of vegetation was at least 52.2%, which is significantly higher than 15%. Therefore, answer D is in fact true according to the graphic. But you've also just made this question a whole lot more difficult than it needs to be. And that's because you didn't trust the steps covered in this video and jumped straight to the graphic, even though you didn't need to. And the result was that you just ended up confusing yourself and wasting valuable time. So remember, the next time you see an infographics question on the test, don't jump straight to the infographic. Instead, you should be following the 4 to 5 steps outlined in this video. I hope you found this video helpful. If you did, please don't forget to like, comment, and subscribe. Thanks as always for watching, and good luck on the test.